2014 Prius, and we're doing the air conditioning on this one. Customer complains it doesn't cool, and just do our visual, use your flashlight. I've only found on this particular Prius there was no oil stains that's visible looking. There's no oil stains on the condenser. It's dry and clean all the way across, going all the way up. So that's visual. Then you use your electronic leak detector, which I have two of them right there. Right now I'm just sensing for the slightest amount of gas coming from the dash. Yes, I know the gas is heavier to air and you should be down there. I've covered this in other videos. There is no dye. Looking at this one, when you look at the sight glass right there, it is nice and clear, crystal clear, so it hasn't overheated. And if you shake it, you can see the liquid move in the bottom. You see the liquid? So that tells you immediately, you know, you don't have to hook up gauges to know that the system should come on for pressure. So if you have liquid refrigerant in there, whatever the ambient temperature is, or the temperature of the engine if everything is hot, the pressure of the refrigerant will almost track 1:1 psi within normal human temperature ranges. So right now the temperature is 52 degrees ambient temperature outside, and so we have 58 degrees here because the engine is a little bit warm. It has been sitting. It's not really warm, but it was moved and it was driven over to here. So a little bit of heat was radiated that's hitting the refrigerant pipes, heating up the refrigerant and raising the pressure above 52 degrees or 52 psi. So that tells you electrically all the switches, safety switches, should close and tell the compressor to come on. I don't need UV dye because I can see there's no UV dye has ever been installed. I did come across one place where there was only the slightest shadowing of oil, and it was on top of the expansion valve right there, just under the sensing bulb, between the line clamp assembly where it has the bracket and the actual expansion valve. There's a little bit, I mean just a slight shadow of oil up there that I rubbed off with my finger, and it wasn't even dark. So I put my leak detector up there, didn't sense everything. All vehicles leak from the day they were assembled because that's how they were designed. The materials that are used in automotive, it's not metal lines everywhere with metal gasket and brazed solid with silver brazing at all connections. There's actually rubber seals and gaskets everywhere. So those are all unmeasurable leak points with normal leak detection equipment available to us. But they do leak. Everything does leak. It was designed that way. It's not a solid round vessel that's hermetically sealed. So with that knowledge and gain, when I hit the button and I turn this car on, we should be able to read some pressures, and let's see what we get. Okay, so let's kick it on, and we have low mileage, 37,000 miles. Okay, pretty good. Okay, and let's kick on to AC. Take it out of recycle. Want to get a little of that engine heat because it's so cold. The AC will just go minimum mode right now. I have no temperature gauges up or anything like that because I know if it does come on, even if it's only half charged, it'll come out nice and cold. It'll come out like 39 degrees, 42 degrees or something like that with half the refrigerant charge on a cool ambient day like today, which is only 52 degrees outside. Doesn't take much refrigerant to drop the refrigerant load. So getting back here, okay, we got 97 psi on the high side. I'm not looking at any temperatures, no temperatures or lines or anything like that. A lot of times you'll see me with my clamps doing temperature. I'm not doing that. I'm just showing you, we're going to stick with simple today. 32 psi on the low side. We're slowly climbing up here, but it's a cold day. It's only 52 degrees outside. So let's watch this for a little while and see what happens. Now you take your hand, this is your most valuable tool. It works better than anything else once you calibrate it. And let me see what it feels like coming with the large line coming out nice and cold. I'd say it's about 38 to 42 degrees coming out of the large suction line at the top, and then grabbing the liquid line below. Yes, it's definitely over 100 degrees because it's definitely warmer than my body temperature, and you know our body temperature is 98 degrees. So when we go over 98 degrees, we feel warmth. And so just for that matter of fact, since it's 106 psi, we know we're over 106 degrees. And that's the liquid line coming out, not the vapor line coming out of the compressor. That's the liquid line going into, coming out of the condenser, going into the expansion valve. The temperature of the discharge line will be much hotter. That's probably about 140 degrees or so. I grabbed that right there, 120, about 120 degrees. So our discharge line, and we're slowly creeping up and creeping up and creeping up. And let's go back here. We have a clear sight glass. So from what the guys on YouTube say in the internet, a clear sight glass means we're full. So we must be good, because AC Pro Can would show good, because if we had the AC Pro Can right now, the AC Pro Can 32 would be somewhere in that green area. So we got to be good. There should be no problems, right? The customer shouldn't be complaining, because we're in the green section of the little AC Pro Can, and we have a clear sight glass, so everything must be perfect and we could just send this customer away, right? No, I don't think so. Let's look into this a little bit more and see what we find. We have a working fan. We don't have a clogged condenser. We have no gross leaks. Let's look for. Okay, I gotta put the camera down. Two hands. What the hell? Alright, sorry guys, but this one's being tough on me. I must be extra weak this morning. Let's get this right there. Oh, I turned you over upside down. That was a hard one. Let's look at the filter. So we'll kill this. Let's go off. And let's kill this. I don't need this no more, because I already did all the leak detection that is needed. And let's take out that. Let's look at the filter. Doesn't seem bad. A little dirty. It's a fine dust. Instead of being heavily loaded with debris like bugs or leaves, there's a packing of dust, and you can't see light through it. This is one of those better, like, HEPA filters. And being a little bit clogged on the HEPA filter type things that are really good at taking the small particles out. But what looks like not too clogged is actually very bad and very restrictive. These filters are restrictive when they start. There's nothing wrong with that to a certain extent if you have allergies. But unfortunately, they plug up about 4 or 5 times faster, and or even more, than the normal cheap filters that look like a fly could fly through, with huge holes in it that you can see through and read a book just about. Great filters if you have an allergy, but and you know they cost a lot more. but you need to change them. If you use it every day and you always have fresh air on, you'll be changing these every 3 months, or you'll just be running with restricted airflow. So I'm going to leave this out for now because this is too restrictive, and it is what it is. So I will just put that there for now. It's not on all the way. Now let me run this again. Now on a cold morning like this, 52 degrees ambient, having a restricted airflow or not, the outside air temperature is so cold that removing the filter won't make too much of a difference. But on a hot 90, 100 plus degree day, makes a big difference when you have a restrictive airflow over your evaporator. And so that's the crucial thing. On the hot days, you want all the air you can going over that evaporator. So I don't hear it on. Oh, I didn't turn it on. I turned on the car, but I didn't turn on the AC. Oh, no, I didn't. Now let's turn it on. There we go. Turn on the car. Turn on the AC. Get it in fresh air mode because I want to suck the hot engine heat out. I don't want to recycle this cold air. Oh, much better flow. I don't need a vane anemometer to measure airflow to tell me this is a stronger flow. It is a much nicer flow. Okay, so that's part of the customer's problem right there. And oh look, bubbles. Why do we have bubbles? Oh, they're going away finally. But with the more airflow going down over the evaporator, more refrigerant is flashing off. And so the expansion valve opens up to maintain that superheat. And so it calls for more refrigerant. So we had, when we started up this time, we had a lot of bubbles inside there, and actually it was so low, it was actually filling up because right away the expansion valve was open and it was trying to keep up with the amount of refrigerant it was leaving through. So we still have roughly the same pressures. We're not using temperatures. Now temperatures are important, but I'm just trying to keep it simple, like everyone thinks about pressures, and you can tell stuff is full by pressures. Unless it's extreme on variable displacement, no, you can't. Okay, so customer was complaining about lack of cooling. Well, I know it had lack of blowing, that's for sure, and on a hot day it would have lack of cooling due to lack of airflow. So I'm going to pull out the refrigerant and weigh it, and let's see what we pull out of the system, and we'll go from there. I'll see you on the next video, on video number 2 coming up.